All right, so sometimes we're given the output of a function and we would like to know what the input was. And that's where an inverse function comes in handy. All right, so the inverse function is the undo of a function. All right, so if we put in x and we get y, then we want a function that we could give it the y value and get back what x was. All right, so um, so if you were to compose those two functions, the inverse and the original function, we should get back x, right? And the reverse is also true, right? So if we put a value into the inverse and get a y value, then if we put y in to the original function, we should get back x. So again, if we compose the two functions either way, we should get x back. All right, because they just reverse each other. The function and its inverse just reverse each other. And so we read this as f inverse, and it gives you the value of x for which f of x is equal to y. Now, one caution is that you have to be careful. You have to be a little careful. Let's see, get this thing to scroll. What's going on? Okay, it's jumping around here. All right, we have to be a little bit careful because it looks like an exponent, right? That -1 superscript looks like an exponent. And but it's not. Now we'll learn more about how exponents work. Maybe you're familiar with how exponents work, but a negative exponent, normally gives you the reciprocal of a function. All right, but this is not an exponent. It's just indicating the inverse. All right, so just have to be a little bit careful about that. So let's take a look at example 3. This gives us a good example of how an inverse could be useful. So we have a formula for Fahrenheit given a temperature in Celsius. All right. So this formula, F is equal to 9/5 C plus 32. If we know the temperature in Celsius, we could plug it into this formula and get the temperature in Fahrenheit. All right. But maybe we want to go the other way. Maybe we know the temperature in Fahrenheit and we would like to find the temperature in Celsius. Now we could set up an algebraic equation and solve it, but we don't, if we're doing this often, we don't want to have to do, solve the algebra every time. Let's do the algebra once and create an inverse function, and now we have a new formula for the temperature in Celsius given Fahrenheit. All right, so that's what we want to do here. We want to create an inverse function, right? So we want to make the input the output and the output the input. Okay, so here in our original function, C, which is the temperature in Celsius, is the input to the function. And what we get out is F. All right, now we want a function where we can input Fahrenheit, F, and get C. All right, so all we're going to do is take this equation, F equals 9/5 C plus 32, and rearrange it as a function for C in terms of F. So we want to isolate C. All right, so this is just algebra, right? We're going to subtract 32 from both sides. That's where I would start here. F minus 32 is equal to 9/5 C plus 32 minus 32, right? I'm subtracting 32 from both sides, and that moves the 32 over to the other side, right? Only it's minus now. All right, now I want to isolate C, and what I can do is multiply both sides by 5/9. If I multiply by the reciprocal, then 9/5 times 5/9 is just 1. And 1 times C is C. All right, so I'm going to multiply both sides by 5/9. All right, so now I have a function for C. Everything here on the right-hand side is just C now, and the thing on the left-hand side is a function for C in terms of F. So I'm going to rewrite it. I'm going to flip it around. I've got C is equal to 5/9 F minus 32. So now we can just use that function. We've done the algebra once, and now we can use this function to take a temperature given in Fahrenheit and convert it to Celsius. All right. So the next question is just asking us to interpret F inverse of 86 equals 30. All right, so remember that the input to the inverse here that we just found, this is our F inverse, right? This is F inverse, and the input to that is the temperature in Fahrenheit. All right, and so this is our temperature in Fahrenheit, so this is our temperature in Celsius. So this statement, F inverse of 86 equals 30, is just telling us that when the temperature is 86 degrees Fahrenheit, the temperature in Celsius is 30 degrees Celsius. All right, so that's all there is to it. The inverses come in handy. Like I said, we only have to do the algebra once rather than doing the algebra every time we're given F and we want to find C. With an inverse, we could just do the algebra once and create a new function. And then now we have a formula that we can use, and we just plug in the Fahrenheit temperature and convert it to Celsius. All right, I will see you for the next video.